Our first model is for a relatively simple habitat home in Sheboygan Falls, Wisconsin. Make sure that you've downloaded the plans on the builder specs. Go ahead and print them if you work better on paper, I know I do, and be sure to grab some highlighters in several colors. This is a very, very, very long unit because we're going to walk completely through generating an energy model for a HERS rating, and that's not a quick task. Feel free to take a break whenever you need to. You want to learn and understand all of this with a fresh mind so you can do it on your own. Let's take a look at what we downloaded. We see that we have the elevations, front, right, rear, and left. This page also has a site plan, so we can see how this house is laid out on the site. The foundation plan is next, and then the first floor plan. We have some interior elevations and some sections. We're given a framing plan and some foundation details, then a roof plan with some eave details. And that's that. I don't see a lot of plan notes, although there are some, and I don't see an HVAC or plumbing plan, but we do have electrical plan information on the floor plans. Before we jump into working with the plans, let's open up the builder specs and give that a quick review. We can see that the foundation type is a conditioned basement. The slab and the foundation walls are all insulated, and we have insulation information for the rim joist and the above grade walls. Aha, look at this. We see that we should disregard the ceiling insulation as shown on the plans because the builders opted for a sealed attic instead. It's a good thing we didn't just jump into the plans and start modeling. We've also been given specs for the doors, windows, infiltration, and duct leakage targets. We know what type of equipment, lighting, and appliances are being installed. We have the home's location and orientation, and we know that there will not be any ceiling fans or on-site power generation. That's actually a lot of great information, and you probably won't get such a nice report in the real world. You'll find yourself needing to make assumptions and ask questions a lot of the time. In this case, let's work with what we've got. Now that we've reviewed what we have, let's move on to step 1. I call this moving in because I'm looking at all the plan details and getting to know the property inside and out. I always start with several colors of highlighters so different colors can represent different locations and items. I highlight all the envelope walls. Walls to ambient I highlight in green. Walls to the garage or cold walls I highlight in blue. Walls to the attic or knee walls I highlight in orange, and adiabatic walls I highlight in yellow. Don't forget to highlight the walls on the foundation plan and all of the main levels as well. Walls to a crawl space will share the colors I just mentioned depending on their location, but open crawl spaces don't have walls, so this is only for enclosed and conditioned crawl spaces. I'll also highlight any envelope floors, so floors over unconditioned spaces such as cantilevers over ambient space or a floor over a garage, and floors over unrated conditioned space. And while we're considering the floors, I always look for and highlight any floor coverings shown in the plans. The highlighting helps me see very quickly whether I got the entire envelope and what areas need to be calculated separately. Plus, it helps me remember what I was thinking when I come back and revisit the plans later to make updates or answer questions about my modeling. Starting with the foundation plan, we see that part of the foundation wall is to the ground beneath the garage, and the rest of the foundation wall is to the ground beneath the outside ambient air. We highlight the wall to the garage blue and the rest of the walls green. Even though all the walls have dirt on the other side, the soil beneath the garage will be impacted by the garage above it. It'll be drier because no rain or snow will fall on that dirt, and it'll be warmer in the winter and colder in the summer. So it needs to be modeled separately from the other foundation walls. You might also have noticed that the foundation wall to the garage is thicker than the ambient foundation walls, so it has a different construction as well, which is another reason that it'll need to be modeled separately. There's another area of concrete against the foundation wall, but that's beneath a covered porch, so it's not an enclosed garage type area. It's open to the elements, so it's considered ambient. If this were instead an enclosed equipment room or something like that, then you'd treat it just like the garage, and that portion of foundation wall would be modeled separately as well. This is a standalone house, so it doesn't have any unrated conditioned space next to it. But if it were a duplex, we would see one of these walls likely next to the other unit's basement. And since we know that the basement is conditioned, that would be a wall to unrated conditioned space. Moving on to the floor. We know this is a conditioned basement, so the floor of this space is our envelope floor. The entire floor is to the ambient ground beneath, so we don't need to highlight the entire floor. We can make a note about it on the plans if we like. Looking closely at the plans, the only floor note that I see is that it's a concrete floor with some insulation, but without any floor covering. This looks to be an unfinished basement. If it had been a finished basement or partially finished basement, we would need to know the floor coverings so we could determine the areas of slab that have differing floor coverings, because each of those areas would have to be modeled separately. Let's move on to the first floor plan. Again, we have the blue cold wall to the garage, and the rest of the walls are to ambient. This level is not the bottom of the envelope, and I don't see any cantilevered floors or floors over the garage on this plan, so we don't have any frame floor information to highlight. However, had the basement been unconditioned, this would have been the lowest level of our envelope. So I'm going to take a minute and show you how you would have highlighted this page in that instance. On this level, we can see that the floor coverings are noted. We have several rooms with carpet and some with vinyl. We even have a dividing line showing us where the carpet and vinyl meet each other. One thing we don't know is whether the stairs are carpeted or not. Since there's a door at the top of the stairs that would normally be closed, the stairs may just be bare wood. If there was a door at the bottom of the stairs, we would need to make some assumptions and note those for follow-up with our field team or the builder. Had the basement been unconditioned and built according to this plan, with a door at the top of the stairs and open at the bottom, this stairway would also be unconditioned, in which case our envelope walls would be the stairway walls, and they would be modeled as walls to unconditioned space. They're also cold walls, but we used blue for the garage, so I would highlight these purple. For now, we don't need to worry about any of those things because the basement is conditioned. Back to step 1. What about the ceilings? We highlighted our walls and our floors. Don't we highlight our ceilings? I find it helpful to highlight the ceilings on the elevations because that can help me understand how the ceilings fit and where they're located as I look at the plan from all sides. This is especially helpful when you have a plan with mixed ceiling types. You want to look for ceiling height notes and highlight those. They help when you're calculating volume, but they also help you note knee walls to the attic. If you have a room with an 8-foot ceiling and then one right next to it with a 10-foot ceiling, there must be a 2-foot wall between the conditioned space of the 10-foot room and the attic over the 8-foot room. That's a wall that you want to highlight in your knee wall color of highlighter. While you're searching the fine print, you want to highlight any model important items that you find in the notes and the drawings. These are items that you know you will need to incorporate into your energy model. For example, the fact that this plan has some 8-inch and some 10-inch foundation walls was one of those notes. The fact that 2x10 treated beams are used on the back patio is not a model important note, and we can just ignore that. While we're highlighting, we also want to highlight the location of the water heater and the hot water using device that's farthest away from the water heater. That's another model important item of note. Based on the pages of this plan, there's a flat ceiling at an 8-foot height, and based on the builder spec document, the insulation will be at the roof deck with a sealed attic. Both of these are important to know for our energy model, but we really don't have anything to highlight about that. But, for example, if they had chosen to vault the living room ceiling to, let's say, 11 feet and then drop back down over the dining room, we could draw that on the elevation, like this. And we can see that we have a true vaulted ceiling for half of it, then attic that would look like a vault from underneath, but would have attic space above for the other half of the vault. Since this is a sealed attic, the vaulted portion would be modeled separately, and the calculation of ceiling to sealed attic and knee wall to sealed attic would be a little more complex. Many times, the floor plans will show ceiling heights under the room names. This plan doesn't do that, so we can look at a section view to determine our ceiling heights. When we look at the section, we see that the basement is 7 feet 9.5 inches tall, the joist area is 1 foot and 5/8 inches tall, and the first floor is 8 foot 1 1/8 inches tall to the drywall ceiling. Remember, the standards tell us to round to the nearest half foot, So we're going to use 8 foot for the basement, 1 foot for the joist, and 8 feet for the first floor. Write this on the plans so you can defend your calculations later if you need to. Next are the model important notes. Starting at the top, we'll be modeling the attic exterior, so the roof pitch is important. We'll highlight that we have a 5/12 pitch. We see that the plans call for 1.5 inch dowel board insulation behind the siding, but our builder's specs just state R19 batt for the wall assembly. We need to make a note of the discrepancy in our list of assumptions. Is there exterior insulation or not? The floor plans seem to show this as well. However, in the model, we want to be conservative until we know for sure, so I would model this with just the R19 insulation until I got an answer on the exterior foam board. The plan shows low-E vinyl windows, which is a model important item. However, we have the actual U and SHGC for the windows, so we'll use that, and we don't need this note. Here's another model important item. We see that the overhang is 1 foot. We'll need that for our window modeling. The plan is showing a sloping lot on the right side, which will impact the above and below grade measurements of our foundation wall, so we may want to add a note that we need to know the grade measurements. We can use what's shown for now, since this plan is for a specific lot, so it may be accurate. Or we can assume the same grade level for the whole house, since this isn't much of a slope, and then ask our field crew to let us know what the actual grade is like. On the foundation plan, we see that we have 2 glass block windows, and we also want to note the location of the water heater. Another thing to watch for on the foundation plan is dotted lines outside of the foundation walls. Many times these indicate a floor above that's cantilevered. In this case, it looks like it's just showing us where the back porch is located, so nothing for us to worry about there. The main floor plan has some plan notes. We see the exterior walls are 2x6 at 16 inch on center. The wall section shows the plan for the foam under the slab and the exterior of the foundation walls. We can also see that the plan is to bring that foam all the way to the top of the wall. This has a note about 1 inch foam on the above grade walls that conflicts with the note that we saw earlier, so there's another comment for our list. We again see a 1 foot overhang and the plans for adding gutters. Gutters will add to that 1 foot overhang, so our field crew will need to get the final overhang depth measurements for us. I don't see anything new on the framing plan or the roof plan. So the final thing on our list is to determine the farthest hot water using item from the water heater. Let's head back up to our floor plans. We noted where the water heater is located, and in the basement we see a washer. Let's mark the location of the water heater on the main floor. We see the bathrooms here roughly in about the same location as the washer in the basement. But look at how far away the kitchen sink is. That's going to be our furthest hot water using item. That's enough coloring now. Let's get to step 2, calculating. We need to calculate the conditioned floor area, the conditioned space volume, the infiltration volume. We need the exterior wall areas and floor areas and ceiling areas and roof areas, all broken out by location and construction. And we need to calculate that distance from the water heater to the kitchen sink. These steps are not set in stone. Once you get comfortable generating energy models, you're free to use whatever process works for you. I always do my calculations by hand or by drawing the plans in SketchUp and then using that tool to do the calculations for me. Once I have pretty much everything I know I'll need, I'll put the data in the energy modeling software. Let's do some calculating. I start with the foundation, and we see that outside-to-outside measurements on our plans of 29 feet 11 inches by 46 feet 7 inches. The standards tell us to round the dimensions to the nearest half foot, so our conditioned floor area for this level will be 30 feet times 46.5 feet, which equals 1,395 square feet. To calculate the volume of this level, we need to know the ceiling height. The basement ceiling height is not shown on the elevations, or the foundation plan, where you will sometimes find it. Here on the wall section, though, we can see the finished floor to finished ceiling height of the basement is 7 feet 9.5 inches, and that means for the volume of this level, we're going to multiply our area, 1,395 square feet, by the rounded height of 8 feet, and we get 11,160 cubic feet. Now we want to calculate the various parts of the envelope for this level. The base of the envelope is our slab floor. Since we don't have any floor coverings and there are no differences in how the slab floor is insulated and constructed, the area of the slab floor is equal to the conditioned floor area for this level. If we had a partially finished basement with carpet, we would need to calculate that area separate from the bare concrete area. The perimeter of the slab is 30 feet plus 46.5 feet plus 30 feet plus 46.5 feet, which equals 153 linear feet. Now to the walls. We have one 10-inch concrete wall with R10 on the exterior, located between conditioned space and garage. This wall is 24 feet long by 8 feet tall, which equals 192 square feet. The remaining walls are all the same construction, insulation, and location. 8-inch concrete wall with R10 on the exterior, located between conditioned space and ambient. So we can subtract the 24-foot portion we just calculated from the 153-foot full perimeter, and we have 129 feet by 8 feet tall, which equals 1,032 square feet. Again, if part of this basement were finished with framed and insulated walls on the inside of the concrete, we would need to calculate that area of wall separately. As we move up the building, we encounter the rim joist area next. According to the wall section, this area is 1 foot 5/8 inches tall, so we'll round that to 1 foot. We see in the specs that the entire rim will have R19 batt insulation. However, a portion of this rim joist is to the garage, so that needs to be calculated separately. This section is 24 feet wide by 1 foot tall, so 24 square feet. The remainder is the 129 feet that we determined for the walls times 1 foot in height, so we have 129 square feet of rim joist to ambient. Rim joist area is not considered conditioned floor area. However, we do want to calculate the volume of the air in this space between our two conditioned levels. The volume will be the area times the height. We know the area is 1,395 square feet times 1 foot high, so that gives us 1,395 cubic feet of conditioned air in the joist area between the two floors. Before we leave the rim joist, there's a consideration you may run into in future plans. Had there been a cantilever floor on the main level, that portion of the rim joist would now belong to that frame floor, so you would not include it in the exterior rim joist areas. You also would not include the volume of the cantilevered floor itself in the conditioned volume calculation because it's not between two conditioned levels. This is a relatively simple plan, and the basement and the main floor footprints match each other. They're both the same dimensions, so we already know what the conditioned floor area of this level is, 1,395 square feet. Sometimes the upper levels will be larger or smaller than the lower levels, so you need to pay attention to the measurements shown and determine if you need to recalculate the area or calculate additional areas to add or to subtract. This frame floor is located between conditioned levels, so we do not need to calculate any frame floor dimensions or areas. The above grade walls are all constructed alike, 2 by 6 with R19 batt insulation, and their locations, lengths, and heights match the locations, lengths, and heights of the foundation walls. So we can just copy those wall areas to this level as well. The conditioned volume will also match since we have the same area and the same ceiling height. While we're looking at the main floor, we can consider our ceiling area. For a sealed attic, we need to know the area of drywall ceiling, and then we will also need to calculate the exterior area of the sealed attic itself, including the roof and any gable walls that are up there. The plan shows a flat drywall ceiling, so the area is going to match the floor area. If there'd been any vaulted area, then there would be more ceiling than floor area. There will not be less ceiling area than floor area because that would mean there's a gap or a hole in the ceiling straight to the outside world. Let's take a look at the roof plan. We can see that the roof over conditioned space is a 5/12 pitch with a center ridge and a gabled end on the front and the back. We can ignore the garage because that is built over the roof decking of the house, which is where our foam insulation is going to be located. To determine the area of the roof and gable walls, we need to pull out that old Pythagorean theorem. A squared plus B squared equals C squared. We know we have 30 feet on each end, so The roof is angling up for 15 feet at a 5/12 pitch to the peak. For every foot over, it goes up 5 inches. So at 15 feet, it's gone up 5 times 15, or 75 inches. Divide 75 by 12, and we know that the peak is 6.25 feet up from the ceiling plane. Now we have our triangle. 15 squared is 15 times 15, which equals 225. 6.25 squared is 6.25 times 6.25, which equals 39. 225 plus 39 equals 264. So c squared is 264, and our c distance is the square root of 264, which equals 16.25. Now we can calculate the area of the roof as 16.25 times 47 feet, which equals 763.75 square feet. We need to multiply that by 2 to get the other side of the roof, so we have a total of 1,527.5 square feet. But don't forget the gable ends. We have a triangle on each end that is to the attic, which brings up another question for our list. Are the gables going to be insulated the same as the roof deck, or the same as the walls? The plans assumed the insulation would be on the drywall ceiling, so there's no help for us there. And the builder's specs are not specific enough to answer this question, so we will again need to make an assumption. We will want to calculate the area of the gable ends separately anyway, because we know from the builder specs that the roof has 2x6 trusses at 24 inches on center, while the walls are 2x6 at 16 inches on center. The area of the gable walls will be the area of a triangle, which you'll remember is 1/2 the base times the height. We already calculated the height as 6.25 feet, so the gable end is 15 times 6.25, which equals 93.75. Again, we multiply this by 2 since we have 2 gable ends, so we have a total of 187.5 square feet. The standards tell us to round that to the nearest square foot. So our roof deck will be modeled as 1,528 square feet, and the gable ends will be modeled as 188 square feet. We have one final calculation to perform in the ceiling attic roof arena. Since this is a sealed attic, we also need to calculate the volume of air in this space. Normally, to calculate volume, we'd use floor area times height. But in this case, with a sloping roof, it's going to be easier to calculate by taking the area of one of the gable ends that we just determined times the length of the space, or 93.75 times 47, which gives us 4,406.25 cubic feet, and we can round that to 4,406. The area of conditioned attic floor is not considered living space, so we do not add that to our conditioned floor area. Now that we have all the areas of the envelope calculated, we can add together the conditioned floor areas and see that our total CFA is 1,395 plus 1,395, or 2,790 square feet. Our conditioned volume will be the volume of the basement, 11,160 cubic feet, plus the volume of the floor joist area between the basement and the main floor, 1,395 cubic feet, plus the volume of the main floor, 11,160 cubic feet, for a total conditioned volume of 23,715 cubic feet. According to the standards, the volume of the sealed attic will only be included in this volume if there's an ACCA Manual JS and either B or D report, which has been verified to include that volume, or if it's been verified through inspection that the heating and cooling equipment serve that area. Since this is a projected rating, no verification has taken place yet, and we weren't provided any ACCA reports. So we're going to exclude that volume from the conditioned space volume for now. However, we do need to add it to the conditioned space volume to get our infiltration volume, which is the entire volume of air inside the air-sealed and insulated envelope. So our infiltration volume is 23,715 plus 4,406, or 28,121 cubic feet. That concludes the envelope calculations, but we still need that distance from the water heater to the farthest water-using item. Earlier, we decided that was the kitchen sink. We have to calculate the distance using right angles and no diagonal runs. So, get out your architecture ruler, or it's also okay to estimate as close as possible using other measurements from the plans. My ruler tells me the sink is about 13.5 feet over and 17 feet down for a distance of approximately 31 feet. Whew, that was a lot of calculating, and we haven't even looked at the windows and doors yet. Step 3 is to put all the data into the modeling tool and generate the model. Make it a habit to create a digital folder for the job. You'll end up with a lot of documentation that you need to retain and provide if requested. You'll also likely end up with several versions of models as you make adjustments, receive the data from the field, etc. You'll need to look up efficiencies in various directories if you've not received efficiency information, and you'll want to place the results of those lookup items in your digital folder as well. Then you'll take the answers to the calculations we just completed, as well as those doors and windows and efficiencies, and enter them into the modeling software. Run the calculation engine of the software tool and handle any errors or warnings that you receive as a result. Then that is your completed energy model. The first thing we need to do is create a digital folder for the job. We really should have done that as soon as we received the plans, and then place the PDFs of the plans and the builder specs in the folder. Determine a naming convention that works for you and your company that allows you to quickly find the folder back when needed. For this example, I'm going to create a Windows folder and name it Mentored 1 Sheboygan Falls, Wisconsin. This is what it looks like with the plans and the builder specs. Let's take a look at those specs. We see that for the mechanical ventilation, space heating and cooling, domestic hot water, and appliances, we have model numbers, but no efficiency information. We'll need the efficiency information for our energy model, so we need to look these up. Let's do some online searching to find the efficiency information that we need for all of these items. I'm going to walk you through some websites, show you how to find the information that you're looking for, hopefully, and I'll give you some extra tidbits too for future ratings that you might have. The first item on our list is for mechanical ventilation, and you're going to find any mechanical ventilation items on the HVI website, Home Ventilating Institute. So the web address for that is https://www.hvi.org. When you get here, you want to go to the Certified Products directory. So we'll click on that. And the Certified Products directory is broken out into 3 parts. You'll see section 1 has bathroom exhaust fans, kitchen exhausters, dryer exhaust ducts, kitchen exhaust fans that are not downdraft, kitchen range hoods, etc. Powered attic ventilators. So all of these are in section 1. Section 2 has the duct termination fittings and soffit vents. And then section 3 has heat recovery ventilators and energy recovery ventilators. Looking at our specifications, it looks like we have a Panasonic ERV, so we have an energy recovery ventilator. We want to go to section 3. We're going to click on section 3 directory. It'll bring us in here, and you'll see it just starts listing all of these that it has. We can filter this by putting in a brand name. Just click the down arrow, and we're going to search for Panasonic because it tells us it's a Panasonic. Just click on it, and you'll see we've got 4 Panasonic ERVs. FV-10VEC1 is the one that we're looking for. So there we are. Click the model details, and we're going to get a lot of good information here. The main information we want is right here. We want our SRE, ASRE, TRE, ATRE. It's under Energy Ratings. So now that we found this information, we want to print it. I'm using the Firefox browser, so for this browser, I hit Control-P. It gives me a nice printout with all of the information I just showed you, including the graph on the next page. And I can print to PDF. I use Microsoft Print to PDF. You may have a different PDF printer on your machine. And when I tell it to print, I'm going to choose our folder, digital folder we just created. There you can see there's the plans on the builder spec. I think I will call this the name of the mechanical ventilation system to make it easy to bring back. So Panasonic ERV. And now I have the ERV information. Our next items are heating, cooling, and water heating. All of those can be found on the AHRI Certified Products Directory, and that is found at ahridirectory.org. So to search for products here, you've already seen me do it once. We're going to look for these items now. We click on model number, product type. We want residential. We'll start with the furnace. So residential space heating furnaces. There we are. And our furnace is a Goodman furnace, GMES 920803BN. As you remember, we only want to put a few digits of the model number so we can start narrowing down our search. We're going to go GMES 92 and see what happens. Let's see, we ended up with only 8 entries, so that's actually pretty searchable. 920803BN. 0803BN, here we are. From this, we want to click on this, on the blue Certified Reference Number tab, because that is going to give us our AHRI certificate. We're going to go ahead and save that file. So right now we're just gathering the information. When I save it, it will save it in the Downloads folder. Then I can grab all the things out of the Downloads folder and move them into my project folder when I'm done finding things. Okay, so my next item then is going to be space cooling. Go for the model number. We want a residential air conditioner under the AHRI rating conditions. Now sometimes you might not know if it's an air conditioner coil, or a heat pump. If you can't find it in one of those categories, search in the other one. So we're going to start at the air conditioners. We see our coil is CAPF 1824B6. So we are going to put CAPF 18. Our outdoor unit, the condenser, is GSX1302. We'll start with that. And let's just do that and not put in the furnace yet to see what we find as far as these two items, the condenser and the coil. Okay, we found 458 entries. There are several of them with a GME furnace, so we're going to go ahead and stick the furnace model number in there too, see if we can find a matched set on all three. GMES 92. We'll start with that. Okay, we're down to 32 entries, and let's see what we can do to further limit our search. We can add a few more digits to our condenser. Let's try that, 130241. Oh, still 32. Our coil, CAPF 1824. Oh, we're still at 32. Let's look through and see if we can find ourselves a match. Okay, so as far as our coil goes, we're seeing that CAPF 1824B6, this asterisk is a wild card, so any of these could be a B. B6, we also have a D on the end of all of these. So we have all of these. So we see that some of these have a TXV and an HSK. TXV is a thermal expansion valve. HSK is a hard start kit. A hard start kit will give the compressor a higher starting torque under a low voltage. So we don't know if those are included or not. There's no information about that, so that we can add that as one of our questions, whether or not it has these. And we see that we have an asterisk here, which that could be our B in the CAPF 1824. This asterisk is the P, CAPF. They all have an asterisk. Yes, 1824 asterisk, that's the B6. So let's take a look at the condenser. We want GSX 130241, which all of these match that as well. So it looks like we're down to the furnace. Let's try our furnace. So far we're looking at GMES 92. Let's put in the 0803 and search again. Oh, down to 16. So now all 16 of these look like they will match our specs. You can see that they are all different brand names, and that's the big difference between them. So our brand is Goodman. We want to go up here to Goodman. It's going to be one of these top two. Now we see that there's no difference between the two as far as SEER rating goes. whether there's a thermal expansion valve at hard start kit or not. So we can choose either of those, and to be conservative, we'll choose the one that doesn't have those items, or we can go ahead and save both of them so that we have them in our file, and then we don't have to look it up again if we find out that it does have a TXV and we want to get the other one. We also see, however, that we don't quite have a full match on our numbers. There's extra letters in here, which this one has an F asterisk at the end that we don't have. The condenser has an F asterisk, which does not match our model number. The coil has this D at the end, which doesn't match our number. And the furnace has an A at the end, which doesn't match our number. So what we can do is go to the manufacturer site and find out what those extra letters mean. You can search for nomenclature, which tells you what the different letters in the different positions of the model numbers means. A lot of times when they're at the end, that has to deal with color of the case or something like that, which does not come into play, so it wouldn't impact our efficiency. So for now, since these are the two Goodmans that we find that are matching, we're going to go ahead and grab them. Let's grab them both and put them in our file so that we can move forward. All right, our next item is our water heater. We're going to go back to the top. We say we're going to go by model number, and our product type now is a residential water heater. Our water heater is an A.O. Smith. The model number is G6-T403NVR. I don't like putting dashes in to start with. We're going to start with G6 and see how they have them listed in the directory. So here's some A.O. Smith, and there is a G6 dash. They do have dashes listed in there, so we'll go ahead and add our dash T40, probably 40 gallon, and search on that and see what and we don't have anything. Let's see if there's any dash T's at all. There's a G6-T5040 and 5050. Instead of searching at the G6, let's try just searching for 4035 NVR. We're not finding that either. So I'd say this water heater is not in the AHRI directory. What that means is that we're going to need to go ahead and use a default for it instead, or see if we can find manufacturer's information. We want to try to go straight to the manufacturer, so we're searching on A.O. Smith, and we see there is an A.O. Smith website. Let's click on that. So now let's try searching on the model number and see where it takes us. This did not return any results, so let's try looking for a water heater. We can see that they have their water heaters at aosmith@lowes.com. So what I'm going to do is open a new tab and just search for A.O. Smith with the model number and see. I did find one at aosmith@lowes.com. G6-T4035NVR. You have to watch out because sometimes the search will give you matches that are close but not exactly the same, and we want to find the same thing. So we're going to go ahead and take a look at that. And it shows us the water heater. Here's the specs. So in our specs, we see here we've got the gallon, we've got the capacity, the rated storage capacity, the UEF. And that's the information that we want. We need that UEF. That's our uniform energy factor. We need to know the rated storage volume for our models. So we've got what we need here. We can look at that. We know that this is where the manufacturer has their information because we saw that on the manufacturer site. So once again, I'm going to print the page so that I can show where I got it. So what I'm going to do is do a screen print, and then I'll scroll down and get a screenshot of the next one. All right, the next thing we need to look up is the appliances. We've got a washer, a dryer, refrigerator, dishwasher. Appliances can be kind of tricky. There's a lot of information you need about them. And so I've got a couple sites that I use for appliances. Energy Star is one of them. You go to energystar.gov and you can see down here we've got refrigerators, washers, and dryers. They also have some heat pump water heaters, air source heat pumps, so you can, if you can't find the information in other places, you can try to find it here on Energy Star. And the second one is the California Energy Commission search system. California Energy Commission allows you to search by model number or appliance type or company, brand, etc., and find information there as well. So we'll start at Energy Star, and we're going to go look for this washer as our next thing to look at. Let's click on washers. It gives us, starts listing all of the washers for us. What we want to do is narrow that search. We can filter by the model number. So we're not going to find it on the Energy Star site. Let's try California Energy Commission. We can search for model number. This dynamic search is going to search as you type in the model number. Standard search will have you enter the model number and then hit search. The dynamic search can pop up a lot of things and make it a little confusing as you're going, and can slow down your computer. So I generally use the standard model search, put in the model number, and hit search. And here we are. So we did find it on the California Energy Commission. We can select that, and it will open up a page for us that lets us see all the information that we need. We can see our capacity. We see our IMEF, Integrated Modified Energy Factor. We see our integrated water factor. And what we don't have on the California Energy Commission site is the labeled energy rating and things that we would want to find from the energy guide itself. But the energy guide does not include our IMEF or our integrated water factor. We also need those. So what I'm going to do is go ahead and print this page. If you have a builder that uses a lot of the same appliances and furnaces and air conditioners and water heaters, you could create yourself a folder of all of the items that they use in their buildings and just be able to grab the PDFs from that folder as long as they match what you're looking for. So that's another way to save some time. Okay, so we're going to save that. And then since we couldn't find it on Energy Star and we don't have all the information we need on the California Energy Commission, we're going to go ahead and see if we can find an energy guide for it. I like to go ahead and put energy guide in my search because a lot of times that will narrow it down to just those entries that actually have an energy guide. And we see here an energy guide for this washer, it looks like. We double check here, WTW 5000D, here is our energy guide. So we definitely want that. That's going to give us our labeled energy rating as well as our electricity and gas costs and our estimated yearly gas cost. All the information that we need except for the 2 items that we needed from the California Energy Commission. So let's go ahead and save this as well. So we have everything that we need for the washing machine. Let's go back to Energy Star and see if we can find our dryer. So I'm going back to the main page, clicking on dryers. We need WED 4950HW. Nope, no WED 4950. So back to the California Energy Commission. And we're going to go to a standard model search and search for our model list. And we can't find the dryer. Let's see if we can find a manufacturer's information for it. Okay, whirlpool.com has it right here. Let's take a look at that. What we want here is our technical specifications. So let's see what we can find. Specifications. What we're looking for with the dryer is its CEF. So we scroll down and see if we can find it. Not seeing it in the specs. So it looks like what we're going to have to do is use the default for the dryer at this point in time. Let's move on to our refrigerator. Click on refrigerators, see what we can find here. We want PVD28BY. We're going to start with that. Oh, look at this. PVD28BYNB. Yay! So we can find our refrigerator. We'll go ahead and click for product details. And it's giving us our information. What we need is our annual energy use, kilowatt hours per year. So we've got that at 722. We could also search for the energy guide on the refrigerator and find that, put it in. But since we found it here, we have what we need. Let's go ahead and download that. Save the file and take a look for our dishwasher. And you may have noticed that Energy Star site does not have dishwashers. Let's try PDT750SS. We're going to start with that. Search. See if we can find it on the California Energy Commission. Okay, it's not there either. But what we really need for the dishwasher is the energy guide. And we can normally find those with a quick search. Okay, so we see that here in geappliances.com we have something that has the correct model number and it says it has an energy guide. So we're going to grab that. And we see here a little picture of the energy guide. We should be able to click on that and get our energy guide. There we are. So we can look and double check to make sure this is PDT7, 4 other numbers, and an F. So that is our correct energy guide for this dishwasher. Let's save that. Okay, so we have found all of the things that we were looking for, or not found them, and we know which things we have to use a default for. Now if you open your folder, you'll see you have an air conditioner AHRI certificate, a furnace AHRI certificate, which I added the AC and the fern in there. They weren't in the original file name. We've got our water heater, 2 pages of water heater information, dishwasher, refrigerator, ERV, the specs, the plans, the washing machine, energy guide, and the washing machine information. What we're missing is our dryer, which we could not find, so we'll have to use a default for the dryer. So we have all the efficiency data we looked for. We can move forward with this step. However, before we go there, I want to also show you the Solar Rating and Certification Corporation website. SRCC is what you're going to use if you do have solar on a building and you need to look up any information about the solar panels. As I've said before, talk to the manufacturer or the installer because they can help you find all the information probably a lot easier than it is for you to find it. However, if you can't, you can go to solar-rating.org and look in their directories. So we will go to the Certified Products directory, and we need to know if we're looking for a thermal collector, a water heating system, a pool and spa heating system, or heating and cooling products. So let's just grab a thermal collector, since we don't have any on this, and you'll see they give you a list. They give you, you can put in the SRCC number from the label and then search, and that will take you right to it. As you pull up something, you can pull up by the SRCC number, you will get the Certified Solar Collector specs. And so this is the file that you would want to print to PDF and save in your folder. And you can look through that and get the information that you need for your model. Okay, we've looked up all those items and placed what we found in our digital folder. I believe that we have everything we need, so now it's time to choose your next unit based on the HERS modeling tool that you're going to be using. You can, of course, go through any of them if you like. There are some very interesting differences between the tools.